we're just going to do an example of some of the data that you might get for this lab. So again, I shouldn't see these exact numbers in your data table because depending on the masses you got, your data is going to be a little bit different. But I wanted to show you how you would manipulate the data that you get in the lab. So if you look at your data table on the back of the sheet, the first question is asking you about water. So let's just say when you took your mass of your water and you subtracted out the mass of the weighing tray, you ended up with 7.1 grams. So we'll just put 7.1 grams in our data table. Okay, now the second question is asking you for molar mass, and molar mass, the units are grams per mole, because for every mole you have that amount of mass. So for H2O, water, just think we're going to need to add up all of the atoms that are in that compound. So in hydrogen, we have 2 hydrogen atoms, and each one has a mass of 1 gram. So we do 2 times 1, and that gives us 2. And then for O, we have 1 oxygen atom, and each oxygen atom has a mass of 16. So if we add up 2 plus 16, our molar mass for water is going to be 18. And the units, it tells you right there in the data table, are grams per mole. So that's pretty straightforward. Now, if we want to get the moles of each compound, what we're going to do is take the molar mass that we just figured out and use that molar mass to convert our mass to moles. So let's see, I'll switch colors here. And so we had measured out 7.1 grams of H2O. Now, if that's what we're starting with and we want to convert that to moles, we simply set up our conversion factor. And you can use your molar roadmap if you need to, but we figured out the molar mass of water was 18 grams. And in every 18 grams, we have 1 mole of H2O. And so from here, we just cross out our grams of H2O because they cancel out. And so to get our number of moles, we would do 7.1 divided by 18 because 18 is in the denominator. And that is going to give us a value of 0.39 moles of H2O. And so that's what we want to put in our data table. For the next question, they want us to tell how many atoms are in that compound. And so from there, what we can do is convert our answer from the problem above and convert our moles to atoms. So again, pretty easy. We just need to use our roadmap. We figured out that we had 0.39 moles of H2O. And if we're going to convert from moles to atoms, you can use your molar roadmap. And you see that 1 mole of H2O is always going to be equal to 6.02 times 10 to the 23rd atoms. Of H2O. And so if we multiply those numbers together, remembering to use parentheses around your exponent, you'll end up with 2.37 times 10 to the 23rd atoms of H2O. And so that's what we're going to put in our box. And if it won't all fit, I mean, try your best to get it all to fit, but if not, at least make sure you put moles and atoms. Okay, now for the very last couple of questions. They're asking, in the first one here, moles of the element. And so if we want moles of the element, not of the compound, but of the element, think of it kind of as like we're counting. We said here that we needed 0.39 moles of H2O for our compound. And so if our compound is H2O, what that means is essentially in order to get 1 mole of our compound, we need at least 1 mole of oxygen. So that would be 0.39 moles of oxygen. And then because we have another atom here, we're going to actually have 2 answers. For hydrogen, we need 2 hydrogens to make up 1 mole of H2O. And so we're actually going to take 0.39 and times that by 2. So 0.39 times 2 gives us 0.78. And so if we were to try to form 1 mole of H2O from what we have here, we're saying we need at least 0.39 moles of oxygen, and then we need 0.78 moles of hydrogen. Because for every oxygen, we need twice as many hydrogen. Now for atoms of each element, all we need to do here is convert the moles that we calculated in the step above, use Avogadro's number and convert that into atoms. So we already did that, essentially, but we can do it again. We did this for H2O, and it would be the same for H2O as it is for O, because it's the same math. So I'm just going to show you what it would be for hydrogen, because hydrogen you would have twice as many. So if we're converting 0.78 moles of H into atoms of H, we're going to put our 1 mole of H on the bottom and 6.02 times 10 to the 23rd atoms on the top. Our moles are going to cancel out, and so we just simply multiply across, remembering to put parentheses around 6.02 times 10 to the 23rd, and our answer is 4.70 times 10 to the 23rd atoms. And so all I did was I converted the value that I got in the step above from moles to atoms. And so again, if I split this up in half, hydrogen we'll put on this side, so 4.7 times 10 to the 23rd. And over here for oxygen, we said oxygen would be the same as H2O, so 2.37 times 10 to the 23rd atoms. Again, hopefully you see it's not incredibly hard, it's just a little bit time consuming.